There is a moment every single night when your brain stops receiving the world and begins creating one. You have done this thousands of times, fallen into a private universe that no one else has ever seen. It felt entirely real while it was happening, and then lost it, almost completely, the moment you woke. Tonight, we follow that experience all the way down, into the science of dreaming. Welcome to Sleepy Science. Wherever you are right now, perhaps lying in the quiet dark, perhaps feeling the soft weight of your blanket, perhaps already noticing your body beginning to soften and let go. Allow yourself to settle into this. We'll drift through 100 sleep science facts about why we dream. From the first flickers of electrical activity that signal a dream is forming, to the hidden emotional work your sleeping mind is doing right now, to the ancient, still unanswered question of what dreams actually are. These quiet journeys through mind science build something gentle between curious people who need rest. A soft like, a subscribe, or sharing this with someone who lies awake too long creates a pathway for more sleepy souls to find their way here, one peaceful night at a time. It only takes a moment, and it means the world to us. One quiet tap, one sleepy soul at a time. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You don't need to hold on to any of this information tonight. Just let the words move through you like a slow current, warm and unhurried. Sense that soft heaviness beginning to gather in your limbs, your thoughts growing quieter, your body understanding, even before your mind does, that it is safe to let go now. Close your eyes and breathe deeply. You're floating, where waking thoughts dissolve into something softer and stranger. Let your mind drift with the quiet current of sleep. And now we begin. Every human being dreams. Not every person remembers their dreams, but every healthy sleeping brain generates them. Sleep researchers have confirmed this through decades of laboratory study. Watching the brain's electrical patterns shift and surge through the night. When electrodes measure brain activity during sleep, certain stages produce a distinctive pattern. Fast, irregular, almost indistinguishable from the waking brain. And that is precisely when dreaming occurs. The absence of dream memory in the morning does not mean the absence of dreaming at night. It means only that the bridge between sleeping and waking was too brief, too abrupt, or too quiet to carry the images across. You have dreamed every night of your life. The average person spends roughly 2 hours dreaming every single night. Across a lifetime of 70 years, that amounts to approximately 6 full years spent in the dream state. 6 years of private, internally generated experience. Of worlds your brain built without your conscious participation. Most of those dreams will never be remembered. They arise, unfold, and dissolve in silence. Complete experiences that exist for no audience. There is something quietly humbling about that. This vast interior life happening in the dark, night after night, whether or not you are there to witness it. Dreaming is not random noise. The brain does not simply misfire during sleep and accidentally produce dream imagery as a byproduct. Research into the neuroscience of dreaming has consistently shown that dream content is organized, emotionally meaningful, and often continuous with the concerns, memories, and experiences of waking life. The dreaming brain is not broken. It is doing something. What exactly it is doing remains one of the most contested and fascinating questions in all of neuroscience. And tonight, we will follow that question from its first hints all the way to the edge of what science currently understands. Dreams occur primarily during a stage of sleep called REM sleep, which stands for rapid eye movement. During this stage, the eyes move beneath closed lids in quick, jerky bursts, a phenomenon so consistent and observable that it gave the stage its name. REM sleep was formally identified in the early 1950s by researchers at the University of Chicago, who noticed that sleeping subjects periodically entered a state of intense brain activity accompanied by these distinctive eye movements. When those subjects were woken during REM periods, the vast majority reported vivid, narrative dreams. This discovery fundamentally changed how scientists understood sleep, revealing it not as a passive shutdown of the brain, but as a dynamic, active, and deeply purposeful process. REM sleep does not happen all at once. It arrives in cycles throughout the night, each cycle lasting roughly 90 minutes. During the first cycle, REM periods are brief, often only 5 to 10 minutes long. But as the night progresses, REM periods grow longer. By the final cycle before waking, a REM period can last 30 to 40 minutes or more. This means that the deepest, longest, and most vivid dreams of any night tend to occur in the hours just before morning. If you wake from a particularly detailed or emotionally intense dream, it is almost certainly a late-night REM period that carried you there. The brain during REM sleep is remarkably active, in some ways more active than during calm waking. The regions responsible for emotion, visual processing, and memory show especially high levels of engagement. The prefrontal cortex, the part of the brain most closely associated with rational thought, planning, and self-monitoring, becomes significantly quieter. This shift in brain activity is thought to explain several qualities that feel universal in dreams: the emotional intensity, the visual vividness, and the way logic seems suspended. In dreams, impossible things feel not just possible, but entirely normal, because the part of the brain that would question them has stepped aside. While the dreaming brain is highly active, the body is largely still. During REM sleep, a process called REM, atonia, temporarily switches off most of the body's voluntary muscles. The signals that would normally translate thought into movement are blocked at the level of the spinal cord. This stillness is protective. Without it, you would physically act out your dreams, moving, running, gesturing, speaking in response to whatever your sleeping brain is experiencing. REM, atonia, keeps you quiet while your mind travels. It is one of sleep's most elegant arrangements, a chemical quieting of the body that frees the mind to move as freely as it needs to. Dreams are not exclusively visual. they engage nearly every sensory system. Most people who dream experience sound within their dreams. Conversation, music, ambiance, the voice of a person they love or miss. Many experience physical sensations, the feeling of movement, temperature, texture, or warmth. Some people dream in smell and taste. Some experience proprioception, that deep awareness of where the body is in space, which is why dreams of flying or falling feel so physically convincing. The brain, in the absence of external sensory input, turns inward and reconstructs sensation from memory, imagination, and something science has not yet fully named. Not everyone experiences dreams the same way. Some people report predominantly visual dreams. Others describe dreams that are more conceptual, more about knowing things or feeling things than seeing them. A small percentage of people report never having visual dreams at all, dreaming instead in pure thought or emotion. People who were born blind and have never had visual experience do not have visual dreams. Those who became blind after early childhood often retain visual dream content for years or decades. The sensory content of your dreams is shaped by the sensory experience of your waking life, which suggests that dreams are not an escape from experience, but a continuation of it, processed and transformed. The emotional tone of dreams leans heavily toward difficulty. Studies analyzing large collections of dream reports consistently find that emotions, including fear, anxiety, sadness, and uncertainty appear more frequently in dreams than positive ones. Many researchers believe this reflects one of dreaming's possible functions: emotional tending. The sleeping brain may be using the relatively safe space of sleep to process difficult emotions, to gently rehearse responses to what feels uncertain, or to metabolize experiences that were too full to integrate while awake. By this reading, a restless dream is not a malfunction. It may be the work being done quietly, the night attending to what the day could not finish. The oldest recorded dreams in human history come from ancient Mesopotamia, written on clay tablets more than 4,000 years ago. In the Epic of Gilgamesh, one of the oldest surviving narratives in any human language, dreams are described as messages from the divine, portents of fate, windows into a realm beyond ordinary experience. Nearly every ancient culture developed its own way of understanding dreams. The Egyptians trained specialist dream interpreters. The Greeks built temples where the sick would sleep in hope of receiving healing visions. Dreams were, for most of human history, considered one of the most direct channels between the mortal world and whatever lay beyond it. Sigmund Freud published his landmark work on dreams in 1900, arguing that dreams were the royal road to the unconscious, expressions of hidden wishes and inner conflict. His dream interpretation system was enormously influential for decades. Modern neuroscience has largely moved away from Freudian dream theory as a literal model of how dreams work. The specific mechanisms he proposed have not held up to experimental testing. What has persisted is a more general intuition that dreams carry emotional significance connected to the dreamer's inner life, an idea that some contemporary researchers find useful as a starting point, even when the underlying explanation looks very different from what Freud imagined. In 1977, two Harvard psychiatrists, Alan Hobson and Robert McCarley, proposed a theory called the activation synthesis hypothesis. They suggested that dreams were the brain's attempt to make narrative sense of electrical signals generated in the brainstem during REM sleep. Signals that, they argued, carried no inherent meaning of their own. The cortex, faced with this input, constructed a story. The theory was influential, but subsequent research, and Hobson's own later revisions, showed that the picture was considerably more complex. Dream content is far too emotionally consistent and thematically coherent to arise from purely undirected neural activity alone. One of the more widely supported current theories of dreaming is the threat simulation theory, developed by Finnish cognitive scientist Antti Revonsuo in the late 1990s and refined since. This theory proposes that dreaming evolved as a biological rehearsal mechanism, a way for the brain to gently practice responses to uncertain or challenging situations in the safety of sleep. The prevalence of anxiety and uncertainty in dream content fits this model well. So does the observation that people under stress tend to dream more vividly and more frequently about challenging scenarios. By this account, an unsettling dream is not a sign that something has gone wrong. It may be the system working exactly as it was designed to, tending to what the day left unresolved. The memory consolidation theory of dreaming has gained considerable support in recent years. This view holds that one of sleep's most important functions, particularly during REM sleep, is the sorting, integration, and long-term storage of memories formed during the day. The hippocampus, a brain structure deeply involved in forming new memories, is highly active during certain sleep stages and appears to replay recently learned information and transfer it to the cortex for more permanent storage. Dreams, in this framework, may be a kind of experiential side effect of memory processing. The brain's narrative system briefly waking to observe what the memory system is doing and weaving the fragments into story. A series of studies by Matthew Walker and colleagues at Harvard, and later at UC Berkeley, demonstrated that REM sleep specifically improves the consolidation of emotional memories. Participants who were allowed to reach REM sleep after learning emotionally charged material showed significantly better recall than those whose REM sleep was interrupted. More strikingly, REM sleep appeared to soften the emotional intensity of those memories over time, preserving the information while gently reducing the weight of it. Researchers describe this as sleeping, to let go of the feeling while keeping the fact. This work suggested that REM, sleep and dreaming, may serve a kind of quiet first aid, processing experience into something more bearable by morning. People frequently report that creative insights arrive during or immediately after sleep. Scientists and artists alike have described waking with solutions to problems that had seemed intractable the night before. The German chemist August Kekulé described discovering the ring structure of benzene after a dream of a snake curling back on itself. Paul McCartney described the melody of yesterday arriving fully formed in a dream. These reports are not merely folklore. Controlled studies have found that REM sleep enhances the ability to find connections between distantly related ideas, a kind of mental flexibility that allows unusual combinations to form. The sleeping brain may be loosening the constraints that waking logic imposes, allowing new patterns to emerge from the quiet. Lucid dreaming is the experience of becoming aware within a dream that you are dreaming, while remaining asleep and within the dream. In a lucid dream, the dreamer may be able to observe, influence, or even gently direct the content of the experience. Lucid dreaming was long considered anecdotal, but in 1975 psychologist Keith Hearn, and independently in the early 1980s, Stephen LaBerge at Stanford, developed a method for dreamers to signal their lucid state to observers using prearranged eye movements while in REM sleep. This confirmed that lucid dreaming is a real and measurable state, distinct from both ordinary dreaming and waking consciousness. Brain imaging studies of lucid dreamers reveal a distinctive pattern. Compared to ordinary dreaming, lucid dreaming is associated with increased activity in the prefrontal cortex, precisely the region that grows quieter during ordinary REM sleep. This partial return of the prefrontal cortex during lucid dreaming seems to restore some degree of self-awareness, while the dreaming state is maintained. Lucid dreaming is therefore a genuinely hybrid state, something between ordinary dreaming and waking, with its own neural signature. It has become an active area of research, with potential applications in the gentle treatment of recurring nightmares and post-traumatic sleep disturbance. Approximately 55% of people report having experienced at least one lucid dream in their lifetime. Roughly 23% report experiencing lucid dreams regularly, meaning at least once a month. Frequency tends to be higher in children and adolescents and generally softens with age, though the reasons for this are still being studied. Some researchers have found that certain meditation practices and mindfulness training can increase the frequency of lucid dreaming. The state appears to be more accessible than is sometimes assumed, a natural feature of the dreaming brain that most people visit, at least occasionally, without ever seeking it deliberately. Dreams can gently incorporate information from the sleeping environment. In sleep laboratory studies, subjects exposed to sounds or spoken words during REM sleep sometimes weave those stimuli into their dream narratives. A word spoken softly nearby might appear as dialogue in the dream. The brain, even in sleep, maintains vigilance, a gentle monitoring of the environment for information that might matter. Most of the time this operates below awareness, but occasionally it reaches through and leaves a soft fingerprint on the dream, a reminder that even in sleep, we are never entirely separate from the world around us. Animals dream. The evidence for this has grown significantly over the past 2 decades. Rats, when allowed to run a maze during the day, show distinctive patterns of hippocampal activity that are then replayed during subsequent sleep. The replayed patterns are so accurate that researchers could often identify which part of the maze the rat appeared to be revisiting. Birds show sleep states associated with neural patterns that resemble their waking songs, suggesting they may dream of singing. Mammals with larger and more complex brains tend to have longer and more prominent REM sleep periods, suggesting that dreaming scales with cognitive complexity across the animal world. Newborn infants spend approximately 50% of their total sleep time in REM sleep, compared to roughly 20 to 25% in healthy adults. Premature infants spend an even higher proportion, sometimes approaching 80%. In the REM state, the large amount of REM sleep in early life has led researchers to hypothesize that it plays a particularly important role in brain development, possibly supporting the growth and organization of neural connections during a period when external experience is still limited. In a sense, the very young brain may be building itself in sleep, using REM activity as part of the quiet architecture of becoming. The content of dreams changes across the lifespan. Children's early dreams tend to be simple, static, and emotionally calm, often featuring animals rather than people. The human social world, with its complex relationships and emotional texture, gradually enters dream content as children grow. By adolescence, dreams have taken on the emotional richness more characteristic of adult dreaming. Older adults show changes in dream content as well, with some studies finding reduced emotional intensity and less frequent difficult dreams in later years. Though the mechanisms behind these shifts are still being explored, dreams appear to be a kind of running companion to each stage of a life, reflecting what is most alive in us at any given time. Here, at the quarter point of our journey, a first answer is already forming. Dreams are not accidents. They are not random noise or meaningless static. They appear to serve multiple overlapping functions: processing emotion, consolidating memory, rehearsing responses to uncertainty, integrating experience, and possibly even generating creative insight. The science has not yet converged on a single definitive answer, and perhaps it never will, because dreaming may not have a single function. But what is clear is that the dreaming mind is working, that it is doing something worth returning to every single night. In every human brain, across every culture and every era of recorded history, every cell in your body has been here before. Not in this bed, not in this moment, but in the long chain of sleep that stretches back through your entire life. Your body has done this thousands of times. This gentle loosening, this slow descent. You don't need to guide it. You don't need to remember how. Even now, without your awareness, your brain is deciding what to keep from today, what to soften, what to set aside. It has already begun. You are already somewhere between the world and something quieter. Now we continue. Sleep deprivation disrupts dreaming in measurable ways. When a person is kept awake beyond their normal sleep time and then allowed to rest, the brain compensates by entering REM, sleep faster than usual, and spending a significantly greater proportion of time in it. This phenomenon is called REM rebound, and it provides some of the strongest evidence that REM, sleep and dreaming, serve genuine biological needs. The brain treats REM sleep as something that must be recovered. When it has been missed, the brain prioritizes its return above almost everything else, finding its way back to the dream state with a quiet persistence that feels, from the inside, like inevitability. The most common dream theme reported across cultures is being chased. This is followed closely by dreams of falling, flying, appearing in public without clothes, arriving late to something meaningful, and encountering a person who has passed. The cross-cultural consistency of these themes suggests that some dream content arises from shared biology and shared human experience rather than purely personal history. The chasing dream in particular appears in reports from cultures with vastly different languages, beliefs, and ways of life. Whatever is generating that dream is not specific to any one place. It appears to be something we carry together across all the distances between us. The sensation of suddenly jolting awake while falling asleep is among the most frequently reported sleep experiences. This jolt, called a hypnic jerk or sleep start, often occurs as the body is transitioning into sleep and is typically accompanied by a brief sensation of falling. One hypothesis is that this may be a vestigial reflex from a distant evolutionary past, a remnant response related to the body's awareness of postural change during the transition from wakefulness. Whether or not this specific explanation holds, the hypnic jerk is a normal and harmless feature of the sleep transition, experienced by a large majority of people at some point. A small physical reminder of the threshold being crossed. People who are highly empathetic tend to report more vivid and emotionally complex dreams. Studies examining the relationship between waking personality and dream content have found consistent associations. Openness to experience, one of the core dimensions of personality, is associated with more elaborate and unusual dream content. People with a tendency to become fully absorbed in mental experiences report more vivid, detailed dreams. The dreaming mind appears to extend and deepen tendencies that are already present in the waking mind, rather than representing an entirely separate mode of experience. The dreams we have are, in some sense, portraits of who we already are. Recurring dreams, the same scenario returning night after night or year after year, are reported by a significant portion of the population. Studies suggest that between 60 and 75% of adults recall having had at least one recurring dream. The content of recurring dreams tends to be emotionally meaningful, often involving themes of uncertainty, loss, or situations that feel unresolved. Some researchers interpret recurring dreams as the brain's repeated attempt to tend to something that remains psychologically present. When the underlying concern finds some resolution, the recurring dream often softens or stops. The brain, it seems, will gently return to a task until it finds a way through. The relationship between dreaming and post-traumatic stress is one of the most clinically significant areas of current dream research. People who have experienced difficulty very frequently develop altered dreaming patterns, including dreams that revisit or closely approximate the original experience. These dreams differ from ordinary stress dreams in their intensity and their tendency to interrupt sleep. They are a recognized feature of post-traumatic stress and represent a case where the emotional tending function of dreaming may become overloaded, carrying more than it can quietly resolve in a single night. Several therapeutic approaches now specifically address dream content as part of broader support for healing. Image rehearsal therapy is one of the more gentle and effective approaches for recurring difficult dreams, developed by psychologist Barry Krakow. This approach invites people to write down a recurring dream, change its content in any way they choose, and then rehearse the altered version in their mind while awake. Over time, this technique has been shown to reduce both the frequency and the distress of such dreams in a significant number of people. The mechanism is not entirely understood, but it may offer the waking mind a new story to bring into sleep, gently changing the landscape the dreaming mind wanders through. It is, in a sense, quiet storytelling as a form of care. People who play video games frequently report being able to exert greater influence over their dreams and more often experience lucid dreaming than those who do not. This observation, replicated in several studies, is thought to reflect the way that habitual engagement with an interactive, navigable virtual environment may gently train the brain's capacity for agency within imagined spaces. The gaming mind becomes practiced at moving through and responding to a simulated world, and this capacity may carry over, quietly, into sleep. It is one of many findings suggesting that what we practice in waking life shapes the terrain of our dreams in ways we do not always anticipate. Smell travels a different path than other senses. Unlike vision, hearing, or touch, which pass through the thalamus before reaching the cortex, olfactory signals connect more directly to the amygdala and hippocampus, the brain's centers for emotion and memory. This unique pathway is thought to explain why a familiar scent can reach so directly into the past, carrying the full weight of a memory before the thinking mind has time to catch up. Interestingly, despite this intimate connection to memory, smell is notably underrepresented in dreams. Most dreams contain no scent at all. The sense most woven into the fabric of our remembered lives remains, in sleep, largely quiet. The dreaming brain constructs faces from memory. The brain has a powerful and specialized capacity for face recognition, with dedicated neural regions that process faces differently from other objects. In dreams, the faces that appear, even faces that feel entirely unfamiliar, are almost certainly reconstructions of faces the dreamer has encountered at some point. The brain does not invent entirely novel faces. It recombines and gently transforms what it already knows, producing composites that feel new but are built from familiar material. Every stranger in your dreams is, in some sense, someone you have already met. The timing and architecture of sleep, and therefore of dreaming, is shaped by two biological systems working together. The first is the circadian rhythm, a roughly 24-hour internal clock located in a small region of the brain called the suprachiasmatic nucleus, which responds to light and helps regulate the timing of wakefulness and rest. The second is sleep pressure, a gradual accumulation of a chemical called adenosine that builds through the day and creates a deepening pull towards sleep. These two systems interact continuously, together shaping when the conditions for dreaming are most likely to arise and how long the dream states within any given night will last. Caffeine works by temporarily occupying adenosine receptors, which reduces the signal that sleep pressure is building. When the caffeine eventually clears the system, the adenosine that was waiting returns to its receptors, which is one reason the tiredness that follows can arrive so suddenly. For dreaming, this matters because disrupting the natural rhythm of sleep pressure and circadian signals can fragment sleep architecture, shortening REM periods and leaving the emotional processing work of dreaming incomplete. The relationship between what we consume during the day and the quality of our inner life at night is more connected than is often appreciated. Alcohol, while often used as a way to ease into sleep, reduces REM sleep during the first portion of the night. This is followed by a REM rebound in the later hours as the body processes the alcohol, which can produce vivid and sometimes restless dreams toward morning. People who rely on alcohol to find sleep may find that the architecture of that sleep undermines both the restorative functions and the quiet emotional tending that REM provides. This does not mean that occasional use causes lasting disruption for most people, but it helps explain why certain kinds of sleep produce the particular quality of unsettled early morning dreams that many people recognize. Many medications directly affect dreaming. Antidepressants that work through serotonin pathways significantly reduce REM sleep, sometimes substantially during peak effect. This explains why many people taking these medications report a noticeable quieting of their dream life, a reduction in vividness, or an absence of dreams altogether. Beta blockers, some antihistamines, and certain other medications have also been associated with changes in dream content and tone. The pharmacology of dreaming is an area of ongoing investigation, with implications both for understanding the neurochemistry of the dream state and for how best to support sleep and emotional well-being alongside medical treatment. Here, at the halfway point of our evidence gathering, the picture has grown considerably more complex and more interesting than the simple question first suggested. Dreams are not just REM sleep phenomena. They are shaped by what we consume, by the care we receive, by the stress we carry, by the experiences we repeat in waking life. They are altered by difficulty and by healing. They respond to the habits we form and the emotions we practice. The dreaming mind is not separate from the waking mind. It is the waking mind, after dark, doing different work with the same materials. You're still here, still drifting through these quiet facts. Take a slow breath. Notice the weight of your body right now, the softness of wherever you're resting. We're exploring consciousness itself, the very thing doing the listening right now. Strange and beautiful, and perfectly calm. Let's drift onward together. Non-REM sleep also produces dreaming, though of a different quality. Sleep scientists long assumed that dreaming was exclusive to REM sleep. But when researchers began gently waking subjects from non-REM stages, a significant percentage reported dreamlike experiences. These non-REM dreams tend to be less narrative, less emotionally intense, and more thought-like in quality, closer to ordinary thinking than to the immersive story experiences of REM dreaming. The distinction between REM and non-REM dreaming has become an important area of research, suggesting that the brain may engage in different types of internally generated experience throughout the entire night. Not only during its most active phases, sleep paralysis is a temporary state in which the stillness that normally protects the sleeping body persists briefly into wakefulness. A person experiencing sleep paralysis is consciously aware, or nearly so, but unable to move. The experience is often accompanied by a sense of presence nearby and vivid imagery that blends the dream state with the waking environment. Sleep paralysis is not physically harmful. It resolves on its own within seconds to a few minutes. But the experiences it generates have been documented across cultures for centuries and are likely the source of many historical accounts of nighttime visitations, a quiet meeting point between neuroscience and the oldest human storytelling. Across dozens of cultures and many centuries, there are descriptions of a presence that arrives in the night, a heaviness on the chest, a figure in the room, the sleeper rendered still. These figures from folklore, now understood to be the cross-cultural signature of sleep paralysis experiences, represent one of the few places where neuroscience and ancient myth quietly overlap. The brain, in the half-waking state of sleep paralysis, registers its own inability to move and may interpret it as something external, generating a sense of presence that gives shape to the feeling. The presence at the bedside, so vivid and so certain, is the brain interpreting its own stillness. Not a visitor, a nicho. Dream content is influenced by our closest relationships in measurable ways. Studies examining dream diaries find that the people who appear most frequently in dreams are romantic partners, close family members, and friends. Strangers appear surprisingly often, as do people who have passed. Deceased relatives appear in the dreams of a significant proportion of bereaved individuals, sometimes years after the loss. These visits are frequently experienced as comforting rather than distressing, and some grief researchers have suggested that they may serve a quietly consoling function, the dreaming mind offering a form of continued presence that waking life cannot sustain. Perhaps the heart, in sleep, keeps its own kind of company. People who are blind from birth have dreams organized around sound, touch, smell, taste, and bodily sensation rather than vision. Their dreams are no less complex, no less emotionally rich, and no less narratively meaningful than sighted dreams. They simply exist in a different sensory register. This finding confirms that dreaming is not fundamentally a visual phenomenon. It is a phenomenon of experience. The brain produces dreaming from whatever sensory and emotional material it has available. The architecture of the dream adapts to the architecture of the dreamer. What remains constant across all dreamers is the experience itself, internally generated, emotionally real, and impossible to fully distinguish in the moment from being alive. Problem solving during sleep has been studied in controlled settings with consistent, if not universal, results. Some well-designed experiments have found that people who sleep after working on a complex problem show improved performance compared to those who spend the same time awake. In these cases, sleep appeared to allow the brain to find patterns or shortcuts that deliberate effort had missed. The effect is not consistent across all types of problems, and researchers continue to explore exactly which kinds of thinking benefit most from a night of rest. But the pattern where it appears, is compelling. The sleeping mind continues working, quietly, on problems the waking mind set aside. The default mode network is a set of brain regions that become active when the mind is not focused on specific external tasks. During mind wandering, inner reflection, and self-referential thought, this network is also highly active during dreaming. Some researchers have proposed that dreaming represents an intensified form of the default mode network's ordinary activity, the same spontaneous, self-directed mental experience that occurs during quiet, waking moments, but freed from the intermittent pull of external reality. By this account, dreaming and daydreaming are not fundamentally different processes. They are points on a continuum, with dreaming at the far end, where the outside world has grown almost entirely still. Emotional significance shapes what the dreaming mind returns to. Not all experiences from waking life appear equally in dreams. Studies tracking the relationship between daytime events and subsequent dream content find that emotionally meaningful moments are far more likely to surface in dreams than neutral ones. This is consistent with the idea that dreaming tends the emotional landscape of a life, selectively attending to experiences that carry feeling, returning to them through the night, working with them in ways that waking consciousness alone cannot. Ordinary events, however routine, tend to fade. The heart keeps its own list of what still needs attending to. The first night, in an unfamiliar place, tends to produce lighter, more fragmented sleep, a phenomenon well documented in sleep research. Brain imaging has revealed that one hemisphere remains somewhat more alert during sleep in a new environment, maintaining a quiet sensitivity to unfamiliar sounds and signals. This asymmetric pattern, where one side of the brain holds a gentle watch, while the other sleeps more deeply, resembles what is observed in certain marine mammals, who can sleep with one hemisphere at a time. It appears to be an ancient feature of the sleeping mind, a remnant of a time when closing both eyes completely in a new place carried genuine uncertainty. At the midpoint of our journey, a central truth has emerged. Dreaming is not a single thing. It is a family of related experiences, produced by a brain that never fully stops, that monitors, processes, rehearses, consolidates, and creates throughout the night. The question of why we dream does not have one answer, because dreaming serves more than one purpose. It is emotional tending. It is a memory library, being organized in the quiet, dark. It is a rehearsal stage for the uncertainties of waking life. It is, perhaps, the closest the brain comes to pure creativity, unconstrained by the demands of the world outside. The answer has been forming all along. We are almost there. Notice how much quieter your thoughts have become. The memories you have been carrying today, the ones with weight, with texture, with feeling, are already being tended, somewhere beneath your awareness. Your sleeping mind is beginning its work, deciding what to keep, what to soften, what to let go. You don't need to help it. You don't need to know what it is doing. Simply feel the quiet of not being needed right now. Your only task is this breath, and then the next. Now we continue drifting. Dreams may serve an important role in social understanding. The simulated social world of dreams, populated with other people, their intentions, their emotions, their responses, may give the brain an opportunity to practice reading and responding to others. A recent line of research has explored the relationship between dreaming frequency and measures of social and emotional awareness, finding some preliminary evidence that more socially complex dreamers show certain advantages in aspects of social understanding. If this holds across larger studies, it would suggest that dreaming extends beyond rehearsing threat to encompass the full texture of human connection, that we practice being with each other, even in sleep. The feeling of déjà vu, that quiet sense of having been in a moment before, may have gentle connections to the dreaming mind. One hypothesis suggests that certain dream experiences create memory traces, stored but not fully tagged, as dream memories. When a waking experience resembles a dream scenario, it may trigger a sense of familiarity without a clear source. Because the dream origin has been forgotten, the recognition feels mysterious, impossible to place. This remains a hypothesis rather than established fact, but it touches on something genuinely interesting. The possibility that the boundary between dream memory and waking memory is more permeable than we generally assume. People in stable, warm relationships report different dream content than those experiencing relational difficulty. Those in secure relationships show less frequent anxiety, dreams, and more frequent positive social interactions in their dream narratives. Those experiencing relational tension show elevated rates of uncertainty dreams involving their partners, more frequent themes of distance or disconnection. This alignment between the emotional state of waking life and the emotional texture of dreams is consistent across multiple studies. The dreaming mind does not escape the emotional landscape of daily life. It inhabits it, turns it over gently, and tries to find its way through. The brain has its own quiet maintenance system that operates primarily during sleep. During the deeper stages of non-REM sleep, channels between brain cells expand, allowing cerebrospinal fluid to flow more freely and carry away metabolic byproducts that accumulate during the day. This discovery, made in the early 2010s and refined considerably since, has given sleep science a new and compelling biological rationale for why rest is not optional. While this clearance process occurs primarily in the deeper non-REM stages rather than during REM dreaming, it is part of the same integrated event. While you dream, your brain is also quietly being restored. Children experience difficult dreams more frequently than adults. Peak frequency occurs between ages 3 and 6, a period of rapid development when the boundary between imagination and reality is still being gently established. These experiences in young children are considered a normal part of development rather than a sign of distress. As children grow older and their capacity for emotional regulation increases, difficult dream frequency generally softens. The transition through childhood dreaming toward adult dreaming mirrors, in its own way, the broader transition from the vivid, immediate emotional world of early childhood toward the more contextual emotional experience of growing up. Time perception in dreams is less distorted than is commonly assumed. a widespread belief holds that dreams occur in an instant, that what feels like a long dream is compressed into a fraction of a second. Research does not support this. Studies in which lucid dreamers signal the passage of time using eye movements during REM sleep suggest that dream time tracks reasonably closely with real time. A dream that feels like 10 minutes appears to occur during approximately 10 minutes of REM sleep. The sense that dreams are instantaneous is likely a feature of how memory reconstructs the experience after waking, rather than an accurate account of how the dream unfolded. Color in dreams has been studied in ways that raise genuinely interesting questions. Reports from the 1940s and 50s, before color television became common, suggested that many people dreamed predominantly in black and white. After color television became widespread, reported rates of color dreaming increased. Some researchers have interpreted this as evidence that the visual media environment we inhabit shapes the imagery our sleeping brains generate. Others have proposed that what changed was not the dreams themselves, but the way people remembered and described them. That the black and white television era may have quietly influenced how dreamers interpreted their experiences upon waking. The question remains open and gently fascinating. Music in dreams has its own quiet quality. People who are deeply engaged with music in waking life, musicians, those who listen attentively and often, report hearing music in dreams more frequently. Interestingly, the music heard in dreams is often novel, not a replay of known pieces, but something new, generated by the sleeping brain from the patterns and relationships it has absorbed. Some composers have reported waking with original melodic ideas that arrived in a dream, whole and already formed. The dreaming brain, freed from the demands of conscious composition, appears capable of making something new from everything it has quietly learned. Nightmares are distinct from night terrors, though both involve fear during sleep. Nightmares occur during REM sleep, involve a full narrative dream experience, and are remembered upon waking. Night terrors occur during deep non-REM sleep, typically in the first few hours of the night. During a night terror, the sleeper may appear awake and distressed while remaining deeply unconscious, with no memory of the episode in the morning. Night terrors are far more common in children than adults and typically resolve without treatment. They are distressing to witness, but not harmful to the person experiencing them, who remains, throughout, held safely in deep sleep. The experience of loneliness affects dreaming. Studies examining the dream content of lonely individuals found more scenarios involving social exclusion and distance. Interestingly, they also found more frequent dreams of warm social connection, as though the dreaming mind was quietly offering what the waking day had not. This compensatory quality has been observed in other areas as well. People who lack certain experiences during waking hours sometimes find those experiences surfacing in their dreams. The dreaming mind appears to have a homeostatic tendency, gently filling in what is missing, offering a version of what the heart still holds as possible. The relationship between diet and dreaming is an area of emerging research. Preliminary findings have associated diets rich in tryptophan, an amino acid found in foods like turkey, milk, and eggs, with more vivid and settled dream content, possibly through tryptophan's role as a precursor to serotonin and melatonin. Eating close to bedtime appears to affect body temperature and metabolic activity in ways that can fragment sleep. While the field is still developing and results should be held lightly, there is growing evidence that what we consume in the hours before sleep shapes the internal environment in which dreaming occurs. That the body and the dreaming mind are more connected than they might seem. Temperature regulation is quieted during REM sleep, the body's system for maintaining core temperature, which works actively during waking and during non-REM sleep through small adjustments in blood flow and muscle activity, becomes largely inactive during REM. This means that during the stage of sleep most associated with vivid dreaming, the body becomes dependent on the ambient temperature of the sleep environment. A room that is too warm can disrupt REM sleep, and with it, the dreaming and emotional tending that REM provides. A cool, still room is not merely a comfort. For the dreaming mind, it may be a quiet necessity. Language can appear in dreams. Dreamers report hearing and speaking complete, grammatically coherent sentences within their dreams, and occasionally reading text. However, written text in dreams is notoriously unstable. When dreamers in lucid states attempt to read something, the words frequently shift, change, or dissolve upon close attention. The visual system in REM sleep does not process symbolic information, such as written language, with the same stability it brings to faces or landscapes. This instability is sometimes used by experienced lucid dreamers as a reality test. Look at something written. Look away. Look again. If it has changed, you are dreaming. Dream sharing is a practice with a long and geographically widespread history. Many cultures around the world developed formal ways of sharing and reflecting on dreams within the community. The Iroquois nations considered dreams to contain messages about the soul's deeper needs and organized communal life around honoring those needs. The Achuar people of the Amazon rainforest begin each day by sharing dreams over morning tea, interpreting them as guidance for the hours ahead. The Malay people of the Senoi practiced collective dream reflection as a way of maintaining social harmony. These practices, across all their different forms, reflect an intuition that dreams carry something worth attending to, an intuition that contemporary science is finding increasing reason to take seriously. The science of dreaming is, by any measure, still young. Despite more than a century of formal investigation, there is no consensus theory of why we dream. There are competing hypotheses, each with supporting evidence, each with its gaps. The emotional processing theory, the memory consolidation theory, the threat simulation theory, the default mode network theory, the continuity hypothesis that dreams simply extend waking life, all have their proponents and their evidence. This is not a failure of science. It is a reflection of the genuine complexity of what is being studied. The dreaming brain is not one thing doing one thing. It is many systems, interacting in a state that we are still learning how to see clearly. Dream recall is something that can be gently cultivated. People who keep dream journals, writing down whatever they remember immediately upon waking before the images fade, typically find their recall improving over time. The mechanism appears to be attentional, regularly directing awareness toward dreams upon waking trains the mind to hold those fragile memories through the transition into full consciousness. Simply intending to remember dreams before falling asleep has also been shown to increase recall in some studies. The brain attends to what we signal as meaningful. Treating dreams as worth remembering appears to make them more available to us. People with certain neurological conditions show distinctive changes in dreaming. Those with Parkinson's disease frequently experience a condition in which the stillness that normally accompanies REM sleep fails to fully engage, and the sleeper may gently act out dream content. This condition often appears years before the more recognized motor features of Parkinson's, and its presence is now considered a potential early marker for certain neurodegenerative processes. The connection between the neural mechanisms governing REM sleep and the pathways affected in Parkinson's disease has become an active and meaningful area of neurological investigation. Dreaming appears to be involved in the consolidation of physical skills. Studies in which subjects learned a new movement sequence and were then allowed to sleep showed greater improvement in subsequent performance than those who did not sleep. The improvement correlated with the amount of REM sleep obtained. This suggests that the dreaming brain is not only processing memories of events and emotions, but is also quietly working on the patterns of movement and skill that constitute physical understanding. People who sleep well after learning something physical may be receiving more than rest. They may be receiving a form of invisible rehearsal. The brain's visual regions are active during dreaming, despite the absence of any light entering the eyes. The images of dreams are generated entirely from within, constructed from memory and imagination without any external source. This self-generated experience is so complete that the brain treats it as real. The amygdala responds to dream anxiety with a genuine emotional response. The heart rate can shift in response to dream events, and the body can produce the full signature of emotion in response to experiences that are happening nowhere but inside the quiet skull. The dreaming brain is not pretending, it is experiencing fully the world it has made. The private nature of each person's dreaming experience is one of its defining features. While people with close relationships and shared experiences may report dreams with similar themes or emotional tones on the same night, this is explicable by the shared emotional life they inhabit, rather than by any transfer of content between minds. Each dream belongs entirely to the dreamer. No technology currently exists to access or fully read dream content from outside, though brain imaging research has made preliminary progress in identifying broad categories of visual experience from neural patterns during sleep. The dream remains, for now, the most private territory we possess. Dream content has been partially approached using machine learning. Researchers at Kyoto University demonstrated that after training a neural network on brain imaging data taken while subjects viewed images while awake, the network could make above-chance predictions about the broad category of content subjects were experiencing during sleep. The decoded categories were general, including faces, outdoor scenes, and objects, rather than specific images. But the demonstration that mental imagery during sleep leaves a detectable pattern, visible to careful observation, was a meaningful step. Full dream reading remains far beyond current technology. But the first small foothold exists, and it points towards something we are only beginning to understand. The philosophical question of dreaming is ancient. How do we know we are not dreaming right now? Descartes used the difficulty of distinguishing dreaming from waking as part of his attempt to find something absolutely certain, a starting point for understanding the nature of knowledge itself. The question remains philosophically open in any fully satisfying way. The practical answer, that waking experience has greater consistency and sensory continuity than dreaming, works well enough for daily purposes. But from the inside, in the moment of the dream, the experience is indistinguishable from being awake. Whatever consciousness is, it appears to function just as completely in the dream as it does in the waking world. Some researchers have studied the transitional state between wakefulness and sleep as a distinct and quietly creative mental space. Thomas Edison reportedly dozed in a chair holding a metal ball, which would fall and wake him at the moment of transition, allowing him to capture whatever imagery had just appeared. Contemporary researchers studying this threshold state have found it associated with flexible and unusual thinking, and some experimental work suggests that brief rests long enough to enter this state, but not full sleep, may carry creative benefits similar to those associated with REM sleep. The mind at the edge of sleep appears to move differently, more freely, across the usual distances between ideas. The question of whether artificial systems can dream is not merely metaphorical. Large neural networks trained on vast collections of information develop internal representations and patterns of activation that bear some structural resemblance to how biological neural networks process and store experience. During certain processes, these networks generate new output that recombines learned patterns in ways not directly present in the training data. Whether this constitutes anything analogous to dreaming remains a matter of deep philosophical uncertainty, touching on questions of consciousness and experience that remain unresolved even for biological minds. But the question itself is interesting. The connection between learning, recombination, and the generation of something new may not be unique to the sleeping brain. By this point in our journey, the intellectual answer to why we dream has become clear. We dream because the brain is a processing system that never stops, and sleep is not an interruption of that processing, but one of its most active and meaningful modes. We dream because emotion requires tending, because memory requires organization, because uncertainty requires rehearsal, because creativity requires freedom from constraint, and because consciousness, wherever it arises, generates experience. The more interesting question, the one that remains at the edge of what science currently knows, is what dreaming tells us about the nature of mind itself. That is where we are going now. Your body has been breathing this whole time, without your asking it to, without your managing it. Heart beating, mind quietly working. You don't need to hold any of this together. The dreaming brain will take over when the time comes. It has done it every night of your life. It does not need your help. It only needs your stillness. Breathe slowly. Feel how the weight of your body has shifted, how it has settled further into wherever you are resting. We are almost at the end now. Just a little further. Every dream you have ever had was real, in the only way experience can be real. It was felt. It left something behind in the body, in the mood of the morning, in the quality of the day that followed. Even what is forgotten has done its work. The dreams you cannot remember have still moved through you, tending what needed, tending, leaving the inner landscape a little different than they found it. Sleep is not empty. It never has been. Every night of your life, something has been quietly attended to inside you, without credit and without fanfare. The grief you did not have time to feel in the daylight, the small joy that did not have room to fully land, the worry that needed somewhere soft to rest. All of it has been visited, in some form, in the hours you were elsewhere. Your sleeping mind has been doing this work for as long as you have been alive. It will continue tonight, without being asked, without needing to be reminded. The word dream comes from an Old English root, meaning joy, or music. Before it described what we see in sleep, it named a quality of experience, set apart from the ordinary, something closer to gladness, to sound, to the feeling of being briefly lifted above the weight of daily things. The sleeping mind has always felt, to those who enter it with attention, like a different country, one that follows different rules, obeys different laws of time and space, and offers, in its own way, a kind of rest that waking cannot provide. In the final REM period of the night, in the long stretch just before morning, the brain is sometimes more active than at any other point in the previous hours. The last dream of the night is often the longest, the most elaborately constructed, the most emotionally complete. The sleeping mind, as the world outside begins to lighten, appears to be making full use of its remaining time, offering something whole before the day begins again. What it says in those final minutes, we rarely remember, but it says it nonetheless. You will dream again tonight. The mechanism is already in motion. The chemicals are accumulating. The circadian signal is moving through its arc. The brain is doing what it has done every night of your existence. Perhaps you are already closer to the first dream than you know. Perhaps the border has already softened, and what you are experiencing now, this quiet, this warmth, this gentle dissolving of the day, is already the beginning of something. Every human who has ever lived has dreamed. Every person, across every era, every language, every corner of the world where people have closed their eyes and let the night arrive. Dreaming is what the brain does when it has time to be with itself. When the world has quieted enough to allow the interior life its full space, you are part of that continuity right now. Part of a thread that runs from the oldest recorded human experience all the way to this moment. This breath, this quiet place where you are resting. What if the dream is not the departure from ordinary experience, but its completion? The waking life gathers impressions, feelings, half-formed thoughts, small moments that did not have room to fully arrive. The sleeping life receives all of it, tends to it in the quiet, and returns you in the morning with something integrated that was not there the night before. Together, waking and dreaming make something whole. Neither alone is the full story of what it means to be a mind moving through a life. The boundary between waking and dreaming is not a wall. It is a shoreline, soft and shifting, with something always moving across it in both directions. The images that arrive just before sleep carry the texture of the day. The mood that greets you upon waking carries something of wherever you have been. The two states are in constant conversation, influencing each other across the hours, shaping the ongoing story of who you are and what you are making of the time you have been given. Tonight, something will be tended inside you. You do not need to know what it is, or guide it, or hold it carefully. The brain knows. It has always known. It has been doing this work faithfully, every single night, since the very beginning. That is what the night is for. Not only for rest, not only for restoration, but for the quiet, unhurried work of becoming, of gathering the scattered pieces of the day and finding, in the dark, how they fit together. We dream because the mind is larger than the day can hold. There is more happening inside a single human life than waking consciousness can fully attend to, more feeling than a single day can contain, more meaning than the hours of sunlight are long enough to find. The night exists so that the rest of us can breathe, so that what is most essential can be carried forward gently into whatever comes next. You have always been dreaming your way toward morning, and morning has always come. And so, our quiet journey through the science of dreaming comes to a gentle close. We began with the simplest observation, that every night, your brain stops receiving the world and begins creating one. We learned that REM sleep carries the emotional tending work your waking hours could not complete. That the brain of Matthew Walker's subjects woke with memories that were intact but lighter. The feeling softened while the knowledge remained. We ended with something older and quieter. The understanding that dreaming is not separate from what you are, but part of what keeps you whole. From the first researchers watching sleeping eyes move in a darkened laboratory, to the imaging work that traced the dreaming brain's neural signature, we glimpsed how vast the question is, and how much lives inside it that science is only beginning to reach. Dreams remind us that the mind is never finished with us. The most essential tending happens in the hours we least remember, in the places we cannot visit while awake. The sleeping brain is loyal to what the heart has held. It returns, night after night, to what we love, to what we carry, to what we have not yet found a way through. Without it, experience would remain unprocessed, feeling would go undigested, and the library of a life would grow cluttered and heavy. By pausing to notice what the night contains, we glimpse the extraordinary care the mind extends to itself, quietly, faithfully, every single night. In these final minutes, take the deepest breath you can, as deep as possible. Think about what it means that every human who has ever lived has dreamed, that consciousness, wherever it arises, generates this, a private world, an interior life, a place that belongs to no one else, that cannot be shared or taken or fully described. You are part of that. You have always been part of that. Let your entire being dissolve into the space between waking and sleeping, where thought becomes image, where the day becomes something softer, where everything that happened today begins its quiet transformation into whatever you need it to become. Prepare for deep sleep. No boundaries left. Only peace. This quiet journey through dream science was made for every restless mind still searching for rest. A gentle subscribe or soft share could carry it to someone who needs exactly this kind of quiet tonight. It only takes a moment. And somewhere, right now, someone needs this particular stillness. One soft tap, one sleepy soul. But there is nothing you need to do right now. Nothing at all. You can allow these thoughts of dreaming to fade now, like the last image before morning, present for a moment, then softer, then simply part of everything, leaving only the quiet, warm, calm behind. Let your breathing deepen. Let your body feel heavier, as if a gentle, patient weight has settled around you, as if the night itself has found you here and is simply holding you. If sleep comes, let it carry you the way a dream arrives. Not with effort, not with will, but with a quiet certainty that you are going somewhere safe, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they are closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your dreaming brain will do this again. It will tend to what today could not hold. But tonight belongs to stillness. Rest well, sleepy soul. And remember, the night was made so that the rest of you could breathe. Good night.